all the numbers being crunched.
18.014.
Yeah, that's what you get for that molar mass right there, and then I'm going to multiply that by 6.89, because that's how many moles we have. So what that will do is that will cross off our moles, and we're going to be in terms of grams. And this will be grams of H2O. So grams of H2O, we got 124. The final answer, 124.123 grams of H2O. Now that is, in theory, how much we should get from our reaction here. So if we start off with this many grams of H2, this many grams of O2, the O2 is going to run out first. It's going to run out first. We know that because there are less moles made of the H2O, the product right here. There was more moles made of the H2O from this starting point for the H2. So the H2 can make a lot more product than the O2. So because of that, it runs out first, and it runs out at this point with 6.89 moles of H2O. So with these starting reactants right over here, we can only make that many moles of H2O, right? Yeah. Then we turn those moles of H2O, so that's just moles, it's like a number of H2O molecules. We turn that into grams of H2O, so we can weigh this stuff, and that's how many grams it is. So this right here is our theoretical yield. In theory, that's how much we should get. Okay, this is our theoretical yield. Now what we've gone through this before in class. I think we kind of touched on this on Monday, and we did yesterday, or we started on Tuesday actually, and then yesterday, and today we've done this one more time. Question?
I'm confused. How do you get the actual?
The actual now. That's a good question. So this is the theoretical yield. This is what you should get in theory with all the numbers being crunched. But let's say you actually run this experiment, and you in front of you, you've got little test tubes, and you are making this experiment happen. Okay? So in the actual environment, you get a value by measuring your final product. So let's say you measure the amount, the mass of the water that you make in this little reaction right here. And then you just happen, it just by chance. Sometimes there's experimental error. Sometimes, I guess it is all experimental error. I don't know. What happens is like some of the H2O evaporates. I don't know. Maybe sometimes you spill it. Maybe sometimes you just you don't zero the scale or whatever it is. But for whatever reason it is, your actual yield is most likely going to be less than this. Almost all the time it's less. Sometimes you get a little bit extra, but then you kind of have to think, well, how would I possibly get extra? There must be some mistake in my whole procedure here. So I guess you could get extra. You could get over 100% yield. But the actual yield, let's say that this is what you actually get, what you actually measure in your experiment. Okay, that's what you actually measure in your experiment. Let's say in this case, I'm just going to give you a number here. Let's say that it's 110.99 grams. Okay, let's say that that's the number that you get when you measure this. Right? So, if that's our actual yield, which you don't know unless you're actually running the experiment, what is your now percentage yield? Let's go down here for this. So if this is the actual, and this is your theoretical, what is your percentage yield? So that's what we call percent yield.
89.4.
Percent yield. Okay, how'd you get that?
3 times. First you divide the actual over the theoretical, and then you multiply that by 100.
That's right. Actual divided by theoretical, and then you multiply that by 100 times 100. So in this case, our actual was
89.4.
Wait, hold on a second. Our actual in this case up over here was 110.99 grams, And then below, what was our theoretical yield? It was 124.123. Believe it or not. Oops, 124.123 grams. And then you multiply that cycle by 100, and you get, what was that again, Sam?
89.4.
89.4%, right? So that's a measurement of how close you are to the correct theoretical yield. So in an experiment, it's kind of telling you how good you were with your experiment. Like, oh, I got 89.4% of what I should have gotten. Kind of like on a test, right? Or a quiz. When you take the quiz tomorrow and you get like a 95%, you think, oh, that's pretty good, right? You should think that. If you think like, oh, a 65, that's pretty good, well, then you've got different standards. But if you've got a 95, you're like, oh, that's great. Yeah, I did pretty good for myself. It's the same thing here, where you have what you actually got. You're trying to get as much of theoretical yield as you possibly can. And you can calculate what you should get through this procedure. And then if you go through the experiment and you actually get this, then that's pretty good. Yeah. Yeah. Now, before we talked about this in a different way. We called it a percent error. Percent error is almost the exact opposite of this. So, for example, percent error would be something like, what would that be? It'd be the opposite part of this, so it would be a 10.6 would be your percent error for this, because it's how much you missed of the percentage. This is how much you've gotten. So it's kind of like opposite sides of the same coin. But that's not all that important for now. What we need to know is how to calculate this. And all the problems that we go through are this. So that's the main idea of the day. Let's go through the warm-up problem right now on page 7 so we can get some more calculations going. We did that? We did the warm-up, the whole thing?
Yeah.
Are you sure about this?
Yeah.
Let's go to the next page. Next page. That's backwards. Keep it going, keep it going, keep it going, keep it going. Page 7.
That is page 7.
Okay, cool. Let me see.
You did it yesterday.
Alright, then that means we only have to do the practice problems over here on this page. Let's do it up.
You want to make me back?
Let's do page 8 right now. If you need help with page 7, let me know.
I'm a dead crowd today. Everyone's so tired.
Yeah, it's a tiring day. Page 8, let's try that one. It says balance the equation and determine the theoretical yield. So let's try that. Let's try it on our own. I'm going to walk around. I'm going to help you guys. Let's see if you can do that. One thing you should know is that when they say something is in excess, the word excess means that there's extra of it. So that is not your limiting reactant. When anything said excess, let's say, like, for example, they say in the problem on page 7, when they say, suppose you have this, 14.1 grams of O2 and excess CH4, that means that the O2 is a limiting reactant. So you don't even have to go through this whole calculation to figure out which one's a limiting reactant. You know, it tells you that O2 is a limiting reactant. Excess just means there's extra of it. So it's not limiting. Okay, I'm going to stop the recording because that's really
You were recording that whole time?
all the new stuff.